Hi there, so this video is on section 5.4. So we're looking at differentiating and integrating exponential functions, specifically e to the x. So first of all, we remember this theorem that is about finding the derivative, or almost gives us a formula for finding the derivative of an inverse function, right? G prime is equal to 1 over f prime composed with g, as long as f prime of g of x is not equal to 0. So we're going to use that to help us find the derivative of g of x here. So we have two functions that we know are inverses of each other. F of x equals to natural log of x, and g of x equals to e of x. So to find g prime, thinking about applying that formula from above, that would be 1 over f prime evaluated at g of x. Well, g of x is just e to the x. So then we think about, well, what is f prime? F prime is the derivative of natural log, which is 1 over x. So we would have f prime of e to the x would be 1 over e to the x, which 1 divided by 1 over e to the x is just e to the x. So what this says is that the derivative of e to the x is e to the x. Weird, right? Which means that the antiderivative of e to the x would be e to the x plus c, right? So the family of functions whose derivative would be e to the x would be e to the x plus some constant. So using this, let's find the derivative of some functions that involve e to the x. So taking the derivative of x cubed times e to the x, that's a product. So we could apply the product rule for differentiation. So first factor times the derivative of the second factor would be e to the x, plus the second factor, and then times the derivative of the first. Okay. For the next one, the derivative of 2 over e to the x, you could use quotient rule, but you also could use exponent properties to rewrite 2 over e to the x as 2 times e to the negative x. Okay. And then the function written in this form, we would be thinking, okay, well, e to a power is the outside function, and then negative x is the inside function. So like a function inside of a function, a composite function, meaning that we have to use chain rule to differentiate. So the 2 will hang out there. Derivative of the outside function would be e to a power. Leave the inside function alone. And then times the derivative of the inside function would be times negative 1. So this ends up being negative 2 times e to the negative x, or if we were to rewrite without the negative exponent, that's negative 2 over e to the x. Okay. Again, thinking about this next function as being a composite function. So 3x squared plus 1 is in the exponent position, meaning we're thinking about e to a power as being the outside function, and then the 3x squared plus 1 as being the inside function. So derivative of the outside would be e to a power, leave the inside alone, times the derivative of the inside is 6x. Okay, so just pulling that 6x forward, which you don't have to do. That would be our derivative. Okay, and then for finding the equation of the tangent line to the graph of f of x equals 2 times cosine of x plus 3e to the x at x equals to 0. Well, to find the equation of the tangent line, we need a point and a slope. Well, we have part of a point. To find the y-coordinate that goes with the x-coordinate of 0, we can plug 0 in to f. Okay, 2 times cosine of 0 is 1, so that would end up being 2 plus e to the 0th power is 1, so 2 plus 3, or 5. So the point that we are finding the equation of the tangent line to on the graph of f would be 0, 5, which is the y-intercept. So we can actually just go straight to slope-intercept form. We have our y-intercept, and we now need our slope. So to find our slope, we need f prime, the slope of the tangent line. So finding f prime, derivative of cosine would be negative sine. So negative 2 times sine of x. And then the derivative of 3e to the x would be 3e to the x. So the slope of the tangent line would be f prime of 0. So negative 2 times sine of 0 plus 3e to the 0th power. Well, sine of 0 is 0. So 3 times e to the 0th power would just be 3. That's our slope. So you can either use point slope form, y minus 5 equals 3 times the quantity x minus 0, or you could go directly to slope-intercept form since we are given the y-intercept. Either one works, but this would be the equation of the tangent line to that point on the graph of f. Okay, multiple choice question. Maybe pause the video and give this one a try, or at least think about it. But for this one, it's a particle motion problem. So it says particle moves along the x-axis so that any time t greater than or equal to 0, its position is given by x of t equals to t times e to the negative a t power, where a is a positive constant. At what time t is the particle's position farthest to the right? Okay, well, for me, I think about, well, when is the particle going to the right? So this is a linear motion problem, which means it's either up, down, left, right, forward, backwards. Because we're asked to find when the particle is furthest to the right, that means it's a right-left situation. So when is the particle going to the right? It would be going to the right whenever velocity is positive. It would be going to the left whenever velocity is negative. So if there's going to be a change in direction, it would occur whenever velocity is equal to 0. So I want to figure out for t greater than or equal to 0, like, when is the particle going to the right? When is it going to the left? And to do that, I would need x prime, which would represent the velocity function. So this is t times e to the negative at. So thinking product rule, we would have first factor times derivative of the second factor. Okay, using chain rule there. And then plus second factor times derivative of the first. Okay, so simplifying that, I could factor out e to the negative at. And then setting x prime of t equal to 0 to determine when the velocity is 0. This would also correspond to a critical value for the graph of x, the function x. And thinking zero product property, well, e to the negative at equal to 0, there's no solution to that equation. And if you think about the graph of e to the negative at, exponential function would be exponential decay. Like if you let a equal to 1, right, the graph would look something like that. Like there's no real number that would make the left-hand side of that equation equal to 0. And then we also have negative at plus 1 equals to 0. So velocity would be 0 whenever t is equal to 1 over a. Now, there are different strategies that you could use here. You might also recognize that, hey, the particle would be the furthest to the right at a relative maximum. We do have only one critical value. So you could think, oh, I'm going to use first derivative test to find a relative maximum. You could also think about using the second derivative test if you want and find x double prime and then plug in 1 over a to see what the sign of x double prime of 1 over a is. That's an option. What I would do is on the interval for t greater than or equal to 0, I would put my critical value of 1 over a. And this is an analysis line for x prime. So I'm plugging in test values into x prime. And then I would just choose, since a is a positive constant, I'm going to let a equal to a value. So I'm going to let a equal to 1, or you can let it equal to 2. So if we do that, then 1 over a is actually going to be equal to 1. And when we choose test values, we could use like 1/2 and 2. And if we were to find like x prime of 1/2, and remember letting a equal to 1, we end up with a positive value. And then finding x prime of 2, we end up with a negative value. So that means the graph of x would go from increasing to decreasing. And 1 over a would be a relative maximum, which from 0 to 1 over a, the particle is going to the right. Which means that when t is equal to 1 over a, that's when the particle's position would be the farthest to the right. And you could also look at the graph, like if you were to graph x of t and just assign a value for a, like let a equal to +1, look at that graph and you'll see that 1 over a, or in that case it would just be at 1, there is a relative maximum, right? Like the graph will go of x of t for t greater than or equal to 0 will go increasing, and then it'll switch to be decreasing. It's really shaky. And again, the positive slopes, that when velocity is positive, indicates that the particle would be traveling to the right. Okay, next question, next example. F of x is sine times e to the negative x on the interval from -π/2 to π/2. So determining on what intervals f is increasing. So again, you can pause the video and try this on your own if you want, and then check your answer after. But f would be increasing when f prime is positive. So we can find f prime using product rule here. So first factor times derivative of the second factor requires chain rule. Second factor times derivative of the first. And finding critical values, right? Because f prime would change signs whenever f prime is 0 or undefined. In this case, we're only looking for where f prime is 0 because f prime is continuous. So factoring out e to the negative x, and then we would have negative sine of x plus cosine of x. No solution to the equation e to the x equals to 0. Okay, think about the graph of e to the negative x. And then for negative sine of x plus cosine of x equal to 0, we'd have cosine of x equals to sine of x. And you're thinking about, so interval from -π/2 to π/2, where is sine and cosine equal? Well, -π/2 to π/2, thinking unit circle, would be Q1 and Q4, right? Negative angles in Q4. Well, Q4, sine and cosine are not equal to each other because x and y are different signs, right? Sine and cosine would be different signs in Q4. So you're thinking Q1, quadrant 1, where is sine equal to cosine? And that would be at π/4, right? You root the point √2/2, √2/2 on the unit circle. Okay, so π/4 is our only critical value. And then we can make our analysis line where we do have endpoints here. Put π/4 on there. F prime, and then choosing test values, like we could use 0 and π/3. So plugging like f prime of 0, well, e to the negative x, so thinking about this version of f prime, e to the negative x will always be positive, so really I can just think about negative sine of x plus cosine of x. So negative sine of 0 would be 0. Cosine of 0 would be +1, so it'll be positive. So f prime will be increasing on that interval. And let's just make sure there is a sign change on the next interval. So f prime of π/3. Okay, negative sine of π/3 would be -√3/2 plus cosine of π/3 is 1/2. So that is a negative value. That sum is negative. So f would switch to be decreasing. So we can say that f is increasing on the open interval from negative pi over 2 to pi over 4, because the question is asking us for open interval. And you could justify and say because f prime of x is greater than 0 on this interval. If you had been asked to justify. Okay, so now integrating with functions that have e to the x. So the integral of e to the x is e to the x plus c. So anytime something else is happening to the e of x, we basically, all we have in our toolbox, we have to try a u sub. So let's let u, in this case, equal to 4x minus 1, because then the derivative of u with respect to x would just be positive 4. So solving for dx, because that's all we would have left to replace, we'd have the integral of e to the u du over 4, which I could pull that 1/4 out front. So the integral of this would just be 1/4 e to the u plus c. Don't forget your plus c as soon as you integrate. And then remembering to substitute the 4x minus 1 back in for u. And we're done. Right? This is all side work for us. Okay, you could maybe try this one on your own. You again have to do a u sub. So you could pause if you want and then check your answer. So I'm going to let u equal to x cubed over 2, and that's because I see, hey, then I'm left with x squared dx, and I know the derivative of that x cubed is going to involve an x squared that will be able to be replace the x squared that's left. So du over dx would be 3/2 x squared. So then rearranging that, you do have the option of solving for dx and then replacing dx and then doing the canceling of the x squareds, or you can say, oh, 2/3 du would end up being equal to x squared dx, right? Because that's what we're trying to replace. So to rewrite this, we could pull the 2/3 out times the integral e to the u du. So integrating that, 2/3 e to the u plus c, and then remembering to substitute the x cubed over 2 back into the exponent position for u. Okay, and again, all side work here. This last one's a little bit tricky. It's kind of thrown people off, but you could also pause the video if you would like and try it on your own. I am again going to do a u sub, and I see that if I were to let u equal to the entire denominator here, then the derivative of u with respect to x would be e to the 2x times 2, which is good because I'm trying to get this 2e to the 2x. I'm not really worried about the 2, but I do want the e to the 2x dx to be replaced. But this actually works out quite nicely, and we can just replace the entire numerator and the dx with du. So then we just have the integral of 1 over u, which you do know how to integrate, du. The integral of 1 over u would be natural log of absolute value of u plus c. And then substituting the 1 plus e to the 2x back in. Now, if this were multiple choice, you might not see an answer that has an absolute value, and that's because 1 plus e to the 2x is always positive. So you don't actually need the absolute value bars there. It wouldn't be wrong to leave it, but you don't actually need them. And there's your side work. Okay, this last question, notice it's calculator active. And part of the reason is because you don't know how to integrate this. But let's look at the question first. So let g be a differentiable function such that g of 10 is equal to 2e, that's important, and g prime is equal to 5e to the negative square root of x, and we need to find g of 2. Well, let's think about this. The function g of x, we would need to use that starting point of g of 10. And then we could add the integral from 10 to x of g prime of t. So then to find g of 2, right, because I know it was thrown out in class, like, oh, find the integral, find g by integrating 5e to the negative square root of x, and then use the g of 10 equals to 2e to find c. And yes, that technically could work. However, you don't know how to integrate by hand the 5e to the negative root x. So we have to fall back on coming up with the function g in integral form, okay? And using that starting point as our initial point. Okay, so g of 2 would then be g of 10, which is 2e, plus the integral. This is what you'd be typing into your calculator, right? Of 5e to the negative square root of t dt. You could also leave it as g prime of t if you wanted. And then after you type that all into your calculator, which remember in your calculator, everything would be in terms of x, the approximation of g of 2 ends up being 1.329. So like this would be the exact value of g of 2. This would be the approximation. And that's it.